Hello everyone, welcome to the channel Amazing Civil Engineering Studies. Here we are with a new video. Today we will study about leveling, its types and terminology related to leveling. We also study about the instruments related to leveling. Leveling. The art of determining relative altitudes of points on the surface of the Earth or beneath the surface of the Earth is called leveling. This branch of surveying deals with measurement in vertical planes. A leveling instrument called level and staff is employed for this purpose along with other equipments which are explained in details. Level. The instrument which is used for leveling is known as a level. It consists essentially of the following parts: a telescope to provide a line of sight, a level tube to make the line of sight horizontal, a leveling head to bring the bubble of the tube level at the center of its run, a tripod to support the instrument. Leveling staff. A straight, rectangular wooden rod graduated into meters, feet, and further smaller divisions, called a leveling staff. The bottom of the leveling staff represents the zero reading. In the most common forms, the smallest division is of 5 mm and graduations are in the form of alternate black and white strips. The purpose of a level instrument is to establish a horizontal line of sight. The purpose of the leveling staff is to determine the amount by the which station, that is foot of the staff, is. Leveling staff is known as the staff rod, leveling rod, and self-reading staff, as the staff readings may be taken directly by the instrument man from the leveling instrument. The new leveling staff in the metric system is 4 meter long and made into 2 pieces of 2 meter length each. This is light, more convenient to handle and facilitates taking readings with greater accuracy than the telescopic type. The width and thickness of the level staff are 75 mm and 18 mm respectively. A folding joint is provided to connect the 2 pieces together with a locking device at the back. The joint provided is such that 1. The staff may be folded to a length of 2 meters. 2. The 2 pieces may be easily detached from one another when required to facilitate easy handling and manipulation. 3. And when the 2 pieces are locked together, the staff is quite rigid at the joint and perfectly straight. Taking staff readings. The staff readings are taken as follows. 1. The instrument is set up and carefully leveled. 2. The staff is held vertically over the staff station. To hold the staff vertically, the staff man stands behind the leveling staff with his heels together in the bottom of the staff and between his toes, and holds the staff in between the palms at the height of his face. The staff is moved till the bubble at the back is at the center. 3. The telescope is directed towards the staff by the instrument man, and it is focused by using the focusing screw. The telescope is moved till the staff is exactly between the vertical hairs of the diaphragm. 4. If the bubble on the telescope is not at the center, the same is centered by using the foot screws. The readings may now be taken. The staff reading is the reading on the staff at which the horizontal hair appears to cut the staff. A staff reading consists of 4 digits. The first digit represents the whole number of meters, the second digit represents decimeters, and the third and fourth digits represent millimeters. Thus if we say that a staff reading is 2.175, it means up to the division at which the horizontal crosshair appear to cut the staff, 2 meters, 1 decimeter, and 75 millimeters have passed. 75 mm means 15 spaces on the staff. When the staff is seen through the telescope, it appears inverted. Therefore, the staff when held on the ground should be read from above downwards and not from below upwards. Definition of important terms in surveying and leveling. 1. Level surface. Level surface is a curved surface which is parallel to the mean spheroidal surface of the Earth, such that every point on this level surface is equidistant from the center of the Earth. The surface of still water in a lake represents a level surface. This is a surface which is normal to the direction of gravity at all points as indicated by a plumb line. The surface of a still lake may be taken as an example of a level surface. As the Earth is an oblique spheroid, a level surface will not be plane but will be a cursed one. Every point on a level surface is equidistant from the center of the Earth. 2. Level line. A line lying throughout on a level surface is a level line. This is normal to the plumb line at all points. Horizontal plane. A horizontal plane through a point is a plane tangential to the level surface at the point. This is normal to the direction of gravity at that point. Horizontal line. Any line lying throughout in a horizontal plane is termed as horizontal line. Vertical plane. A vertical plane is any plane containing a vertical line. A vertical line at any point is a line normal to the level surface at that point. A plumb line is an example of a vertical line. Datum surface. This is an arbitrary surface with reference to which the elevations of points are measured and compared. Elevation of a point. Elevation of a point is the vertical distance above or below the datum. This is usually called the reduced level (RL) of the point. This may be positive or negative accordingly as the point is above or below the datum. Line of collimation. The line of collimation or the line of sight is the line joining the intersection of crosshairs to the optical center of the object glass and its continuation. Axis of bubble tube. The axis of bubble tube or level tube is the line tangential to the longitudinal curve of bubble tube at its middle point. This is horizontal when the bubble is centered. This is also called bubble line. Vertical axis. The vertical axis is the line about which the telescope can be rotated in a horizontal plane. Backsight. A backsight (BS) is the first staff reading taken after setting up the instrument in any position. This will always be a reading on the point of known elevation. Foresight. A foresight (FS) is the last staff reading taken before moving the instrument. This will always be reading on a point whose elevation is to be determined. This reading indicates the shifting of the instrument. Intermediate sight. An intermediate sight (IS) is any staff reading taken on the point of unknown elevation after the backsight and before the foresight. This is necessary when more than two staff readings are taken from the same position of the instrument. Change point. A change point (CP) indicates the shifting of the instrument. Both backsight and foresight are taken on a changed point. Height of the instrument. The height of instrument (HI) is the elevation of the plane of collimation when the instrument is leveled and not the height of the center of the telescope above the ground level. Benchmark. A benchmark, B.M., is a fixed point of reference of known elevation. The reduced level of the benchmark is used to determine the reduced levels of other points. These may be classified in leveling and surveying as 1. GTs, Great Trigonometrical Survey, benchmark, 2. Permanent benchmark, 3. Arbitrary benchmark, 4. And temporary benchmark. The GTS benchmarks are those established by the survey departments of a country. These have been established at intervals all over the country with very high precision with reference to the main sea level as the datum. As the intervals of the GTS benchmark is large, to facilitate the survey works, government agencies such as the PWD, Public Work Departments, etc. have established benchmarks between these GTS benchmarks at closer intervals. Permanent benchmarks. The benchmark in the below picture is known as permanent benchmarks. These are marked on well-defined and permanent points such as milestones, corners of plinths of buildings, top of parapets of bridges, etc. Arbitrary benchmarks in small surveying and leveling works. The reduced level of a well-defined reference point is arbitrarily assumed. These are called arbitrary benchmarks. Temporary benchmarks are the reference points which are established when there is a break in the work. This becomes necessary when the whole surveying and leveling work cannot be completed at a stretch. The survey work is closed on a permanent point which can be easily located when the work is again resumed and started from the same point. Types of leveling instruments used in surveying. Leveling instruments are employed for determining the relative heights of different points on the Earth's surface. A level essentially consists of a telescope to which a bubble tube is attached such that the axis of the bubble tube and the line of collimation of the telescope are parallel to each other. The instrument is provided with leveling screws by which the bubble tube is centered, and the line of collimation is brought into a horizontal plane. The leveling instrument, irrespective of its type, essentially consists of leveling head with foot screws, telescope, level or bubble tube. The leveling head usually consists of two parallel plates. The upper plate is supported over the lower plate by 3 or 4 foot screws or leveling screws by which the instrument may be leveled. Most of the modern leveling instruments are designed to have 3-foot screws, because they are easily leveled. The telescopes used in surveying instruments consist of metal tubes, one moving axially within the other. There are mainly 2 types of telescope. 1. The external focusing telescope, and 2. The internal focusing telescope. Most of the modern leveling instruments are designed with internal focusing telescope. The level tube is used for the temporary adjustment of the instrument. Without the correct adjustment, the whole. Types of leveling instruments. According to the general arrangement of various parts, the levels may be classified as dumpy level, Y-level, reversible level such as Cooke's reversible level and Cushing's level, and tilting level. 1. Dumpy level. In the modern form of dumpy level, also called solid dumpy level, the vertical spindle and the telescope are rigidly fixed, so that the telescope can neither be rotated about its longitudinal axis nor removed from the supports. This leveling instrument is more stable when compared to 2. Wire level. In this instrument, the stage carries two Y supports in which the telescope is fixed. To the body of the telescope, two hand collars of equal diameters are fixed. These collars rest on the Ys. The telescope can be rotated about its longitudinal axis, or it can be taken out and placed end for end in the Ys. A clamp and a tangent screw are provided to facilitate accurate sighting of the objects. This is a very delicate instrument and consists of a large number of loose and open parts. Due to the reversibility of the telescope, the instrument may be more easily tested for permanent adjustments. 3. Cooke's reversible level. This leveling instrument combines the good features of both the dumpy and the Y levels. By loosening the screw, the telescope can be rotated about its longitudinal axis and can also be withdrawn from the sockets and placed end for end. 4. Cushing's level. Cushing's level is in that type of leveling instruments in which the telescope is rigidly fixed and the collar is in a dumpy level. The two ends of the telescope barrel have equal sockets which can either receive the objective or the eyepiece and diaphragm. Reversal of the line of collimation may be established by interchanging the objective and the eyepiece. The eyepiece can be rotated in its fitting. 5. Tilting level. In the above four types of leveling instruments, the line of collimation is at the right angle to the vertical axis, if the instrument is in the permanent adjustment. Therefore, when the bubble is centered, the line of collimation is made horizontal and the vertical axis is made truly vertical. In the tilting level, the telescope along with its bubble tube can be leveled by a micrometer screw without using the foot screws of the instrument, that is, the line of collimation may be made horizontal independent of the vertical axis. Therefore, the line of collimation may not be at right angles to the vertical axis. Originally, the tilting levels were designed for preliminary works only, but now they have become very popular and are being used for ordinary leveling also. As the micrometer screw tilts the telescope in the vertical plane, the level is called a tilting level. When a tilting level is used for leveling work, the vertical axis is only approximately set vertical by leveling screws. Advantages. The advantage of tilting level over other types of leveling instruments is that as the instrument is to be only approximately leveled by using the foot screws, much time is saved, which would be otherwise lost in bringing the bubble exactly to the center of its tube by using the foot screws. Another advantage is that the grades or lines with a particular gradient can be laid by means of the micrometer screw.